This lesson is part 3 of the binomial theorem. We're going to be going through two different types of questions today. I think they're actually very tricky questions, so you really have to have a good understanding of the binomial theorem, why it works the way it does, so that you're not trying to memorize so much. So our two objectives for the day are to find a particular term in an expansion. The expansion would be really large, so we'll ask you for a specific term in a large expansion. And then we're also going to ask you to find the coefficient of a specific term, and I think these ones are definitely the trickier of the two. But let's start with a formula here, a definition for the Arth term of an expansion. So, meaning if I asked you for the 8th term of an expansion, then 8 would equal R. Okay. So this formula here, you can take a look at it, defines how to find that term. Now, again, it's just another formula, and if you try to memorize this is so much for you to try to memorize. So I'd rather you understand where this formula comes from and why it looks the way it does. So I want to consider finding the third term of the expansion of a plus b to the 4th power. Okay? So we know by the binomial theorem that we have 4 choose 0, the first term 4 choose 0 times a to the 4th times b to the 0 plus 4 choose 1 a to the 3rd, b to the 1st, then 4 choose 2, a to the 2nd, b to the 2nd, then 4 choose 1, a to the 1st, b to the 3rd, and then finally, oops, I didn't mean to do 4 choose 1, sorry, 4 choose 3. Then finally 4 choose 4, a to the 0, b to the 4th, okay? So let's take a look at that third term here. Okay, now, in our formula, we have n choose r minus 1 times a to the n minus r minus 1, which is why it turns into n minus r plus 1, by the way. And then we have b to the r minus 1. Well, why is that? Well, of course, in our binomial expansion, we've talked about this pretty much at length before. This should equal that exponent that b term is raised to. So here you're seeing that as well. We have 4 choose 2 and b squared here. And then obviously that this term here has to start with n. The total between these two terms together has to be n. And then we're subtracting away this exponent here, right? The total number is n. Subtract away r minus 1 to arrive at n minus r plus 1. So I think it's actually worse to try to memorize this formula rather than understand where this formula is actually coming from. But essentially, all that you really need to understand is that for the third term, we actually want to use 4 choose 2 because we started counting with 0. Okay? The first term was 4 choose 0, which is why everything from here, this is the first term, here's the second term, notice that it's 1, here's the third term, this is a 2, the fourth term, this is a 3, and so on. Okay? So that's going to come into play now when we do this next question. Let's try to do that without even using a formula. We have find the 12th term in the expansion of x minus x. Alright, let's start with what we know. Since this is the 12th term, then this should be 18 choose 11 for the coefficient. That binomial coefficient should be 18 choose 11. Now we normally take, I'm going to use a and b for right now, and then we're going to substitute that in. We would have a to the 7th power, because b has to be to the 11th power. This has to match this exponent. So we know that this is a to the 7th, b to the 11th. So I'm not even needing to use the formula at all. Now, let's substitute in, our a and b term here. So I have 18 choose 11, x to the 7th, and then negative x squared is my b term to the 11th power. So let's simplify this. I can use my calculator here to calculate 18 choose 11. So I get 31,824, then x to the 7th times a negative x to the 22nd power. So really that coefficient here, since this is negative, it's going to affect what the overall coefficient is. This term is negative 31,824 x to the 29th power. So pretty easily I just found what that 12th term is. So the 12th term. Okay? All right, let's try another one. We're going to find the 5th term in the expansion of root 3 minus 1 to the 7th power. So we know that for the 5th term, that coefficient, the binomial coefficient, should be 7 choose 4, a to the 3rd power, and b to the 4th power. okay, because these two have to add up to 7. So let's substitute in now root 3 and negative 1 here for a and b. So I have 7 choose 4, the square root of 3 cubed, times negative 1 to the 4th power. Now this time that negative 1 actually ends up being positive. We're taking negative 1 to the 4th power, so our term should be positive overall. And then I'll use my calculator to do 7 choose 4. So here I have 35. 7 choose 4 is 35. Then root 3 cubed is actually going to be 3 root 3, and then multiplied by 1. So when you're finding this fifth term here, make sure that you're multiplying now 35 times 3. That binomial coefficient is now going to multiply by a factor of 3 here. So we have 105 root 3 would be that fifth term in this expansion. Okay. This next type of problem that we're going to work on, which is to find the coefficient of a specific term, is what I think is the more difficult of the two. It's a little bit more abstract, and you really have to have a good understanding of the binomial theorem in order to set up these questions. So here the vocabulary also is changing a little bit. It says find the coefficient of the term containing x to the 4th. So this time we don't know which term number it is, and the only information that they're really giving us is that we want to know the specific term that has x to the 4th in it. So let's consider this expansion. If we were to try to write the binomial coefficient at first, well, we have 30 choose some number because we don't know what term number it is, so we can't really fill this part in. So that's not really going to help us anything, so I'm going to erase that. And I want to consider the fact that I want x to the 4th. Okay, so I want to take x, raise that to some power, and y squared, raise that to some power. We're going to call those powers a and b for right now. Well, we know, basically, we do know two little things. We know that a and b together should add up to 30. Okay? We also know that a should equal 4 because that's the whole point, is we're trying to find the term that contains x to the 4th. So basically this is a system of equations where we have a equaling 4 and therefore b equaling 26. Now that I know that this is x to the 4th times y squared to the 26th, now I know what I should put inside my binomial coefficient. Here I should have 30 choose 26 because these are supposed to match. Okay, so now I have the term 30 choose 26, x to the 4th, and then y to the 52nd power. So now I want to look at 30 choose 26. That was the whole point of the question, right, is to find the coefficient. So let's find that coefficient. So using my calculator, I get 30 choose 26 is 27,405. So this is the term, right? This would be the actual term, but the coefficient is what I'm asking for. So I'm going to write the coefficient is 27,405. Make sure that you're always answering the original question, okay? Let's try what I think is an even more difficult question here. This next example, it says find the coefficient of the term containing a to the 9th in the expansion of a plus 2 root a to the 10th. So the reason why this is more difficult is because the last term that we worked on only had the x power here. I think it was y squared was the other one. Well, x to the 4th was the only way to get an x term, was taking that first term and raising it to some power. But now we have two terms with an a involved, so this is going to be a bit trickier. So let's break it down like we did the last problem. We know that a to some power, a to the 8th, and our b term, 2 root a to some power, let's call them a and b again. We know one of two things. We know that a plus b has to add up to 10. These exponents here have to add up to that overall n, right, the degree of that expansion. So there's one of our equations. Now we also know that we're looking for the term that contains a to the 9th. So if I were to, find the actual product of a to that power times 2 times a to the really 1/2, I'm going to rewrite that real quick. Okay. I know that if I were to actually look at the a terms only and add them up, well, a plus 1/2 b has to add up to 9. right? The a term here and the a term here has to combine to give me an exponent of 9, because I'm looking for the expression that gives, or the term that gives me a to the 9th. So I have a system of equations now, a plus 1/2 b equals 9, and I'm going to solve this system of equations. So the reason why I have 1/2 b is because these would be multiplied together, okay? And so to solve this, I'm just going to subtract that whole line here. I have 1/2 b then equaling 1, so b equals 2. And if b equals 2, then a must equal 8. So the term itself was a to the 8th power times 2 root a to the 2nd power. And therefore, the binomial coefficient here should be 10 choose 2, right? We want to match that exponent here. So 10 choose 2. Now when we look at that, we don't want to just take 10 choose 2, which is actually 45 here, because if I were to simplify this whole thing out, I actually have 2 squared here, which is going to affect that 45. That coefficient is not just 45, so I have square root a squared also, which is going to give me a. So overall I have 4 times 45, so 180 a to the 9th would be that term. Okay, taking the 4, multiplying by the 45, a to the 8th, and a gives me a to the 9th. So I obviously found the term correctly. Now I want to answer the original question, which is the coefficient. So the coefficient here, don't get tricked by that and just write 45. It's actually 180. Now the last question here ramps it up even more in the difficulty level here. We have a couple things. It's similar, but similar way to solve, of course. Well, let's find the coefficient for the term that contains x to the 13th in this particular expansion. So again, we don't know what the term number actually is, so trying to do the binomial coefficient won't help because I don't know what number to choose. So let's start with our a term here. X squared raised to some power, and our b term, negative 2 over x raised to some power. Well, I know one of two things here. I know that a and b together have to equal 11. I also know that 2a and negative b has to equal 13. Now, if you're wondering where I'm getting this equation from, look at your exponents. I want to get 13 total, right, for the x's. Notice I have two x's here, so my a and b will have to be taken into account here. But I have 2a, and then this x here, if I want to rewrite that, that's x to the negative 1st power. And if I distribute that b, it ends up being negative b. So that's where that equation, if you're wondering, is coming into play. So now to solve this, I have 3a equaling 24, so I'm just going to add these two lines together. A will equal 8, and therefore b will equal 3. So I have x squared to the 8th power multiplied by negative 2 over x to the 3rd power. So that means the binomial coefficient here would be 11, choose 3. Again, I want to match that exponent here. And from here, I'm going to simplify. So I have 11, choose 3, which I'll type into my calculator real quick. So I have 165, x to the 16th. Then here, when I distribute that 3 here, I should get negative 8 over x to the 3rd. So I end up getting 165 times negative 8, but let me just simplify. So I do, in fact, get that x to the 13th power here, by the way. So I would always verify that you're doing that. I'd multiply the whole term out just to make sure that you're answering the specific question, because it's supposed to contain that particular, I don't know why it's not erasing. Or what the heck? Sorry. Anyhow. That was x to the 13th, so just make sure it verifies with that. So then you'll just take 165 and multiply that by negative 8 to figure out what your coefficient is. So that's negative 1320. So my final answer here should state what the coefficient is, and that's pretty much all you got to do. So it is tricky, especially making sure that you understand how to write these equations. This is the hard part. So tomorrow you're going to get some practice. Make sure you ask some good questions and stay productive. All right, nice job.